Hello my friend, you are welcome to my channel. This video is a part of our ongoing generative AI video series, course series, right? And as of now, we are learning about perceptron model. And in my previous class, I had discussed about how the training happens, and we try to establish a graphical or geometrical intuition behind the training happens, right? So in this video, I will extend the same concept. This is the second part of our training, the perceptron model. And in this video, we will talk more about the mathematical intuition. And this is very important formula called perceptron update rule. Okay. So in previous video, we understand graphically, and in this video, we will try to understand mathematically that how the perceptron training happens. Okay. So without much delay, let's get started and let's understand in very depth how the training happens mathematically in Perceptron. Let's get started. In today's class, we are going to learn about Perceptron training in detail. In previous class, in my previous video, I have already discussed about the geometrical or graphical intuition behind the training, how the training happens graphically, right? So in this video, we will try to again extend the same concept and we will try to understand in very detail about perceptron training, how it happens, okay? And I will highly recommend, my friend, if you haven't seen the previous video, go and watch. Otherwise, no problem. I will give a very small recap in this video, and then we will understand how the perceptron training happens. Okay. So in this video, what we're going to learn, this is a very important fact, important concept, is about perceptron update rule. Okay. This is what we're going to learn in this video, that how this perceptron update rule we generate or we find out, and on basis of this update rule, the whole perceptron trainings happen on the basis of update rule. Okay. And if you have no any foundation concept what is perceptron, for that I have already created my previous video where I have talked about very detailed what is perceptron, the basic concepts. But if you're watching this video, then I'm assuming that you have a basic foundation about perceptron. What is the perceptron? I'm assuming that you know that. Okay. So now let's start our class and let's understand very important concept which is called perceptron update rule, and let's understand how the perceptron training happens. Okay. So in order to explain that, I'm using very small kind of data set, and this data set I have been using in all my classes. Okay. So let's suppose I have this data set. I'm taking very small data set. So I have a salary feature and I have a city feature and I have another column called purchase. Okay. So I'm saying that it's a sales data. By the way, it can be a company sales data. And here, basis of salary and city, I'm predicting whether this product has been purchased or not purchased. Okay. So here I'm giving some hypothetical, it's just a random data. Okay. It's not a real data. So let's suppose salary is 2 and city comes 1. City can be, I'm just giving a numerical presentation of city. It can be any city. It can be categorical data like Delhi, Mumbai, anything. I'm just giving the numbers. Okay. So let's suppose hypothetically, if city is 2 and city is 1, I'm saying if purchase happened. If purchase happened, then I'm representing by 1 because it's a classification problem. If salary is 4 and city is 2, I'm saying purchase not happened, so I'm representing by 0. If salary is 3 and city is 1, I'm saying purchase happened. And if the salary is 5, this is 5. Okay. The 5 and city is 4, I'm saying purchase not happened. It's a very simple data. Okay. And if you have already have the basic understanding what is the perceptron, in my previous video I discussed that perceptron is nothing but in 2 dimensions, it's just a straight line, or it's a plane, it's a hyperplane, right? Which try to separate two different cluster of people or cluster of points. Okay. So that's I think that's understanding you have already. I have discussed that. So in order to explain that, let's assume that I'm representing this perceptron on x-axis and y-axis. Suppose this is my line. Okay. Suppose I found that this is my perceptron, and the perceptron equation, you know that what is that equation? W1 x1 plus W2 x2 plus b. Okay. This is the perceptron equation. I hope this all thing, everything I have already discussed. If you have no, again I'm again saying, if you have no foundational concept about perceptron, then you have to watch my previous video. Okay. So let's assume that this is the equation of perceptron. Okay. And let's suppose there are 2 points. Okay, suppose this is I'm representing this one, red one, by this point. Let's suppose this point. So this point is saying that it is above the line. I mean, because this line is dividing my whole area into two regions. Okay, this is the first region, which is above the line. I'm calling it as a purchase region, and another region is below the line. I'm calling it not purchase region. This everything again I'm reiterating everything I have already discussed. This is a basic foundation concept. Okay, so let's suppose this point. So this point is representing that purchase happened. Okay, and this point is representing purchase happened because it is falling in the purchase region, and this point representing that this purchase not happened. Okay, so let's assume that this point is the correctly qualified point. I mean, my perceptron, my line is predicting that purchase is happened and actually purchase happened. So it is not misqualified. It is rightly qualified point. Okay. Similarly, this point. So my model is saying that this point, according to this model, purchase is not happened and actually purchase not happened. So these 2 points are in the right reason. Okay. But suppose this is the red point. So red point are all the point which belongs to purchase happen, and this yellow point or blue point is those point which purchase not happen. Okay. Now here I'm I'm showing 2 points. Okay. This red points. So red point belongs to those cluster which purchase happen. Okay. So here this point, uh, yeah, you can see that this point is a misqualified point. Okay, and again this point. Okay, so this point actually my model is saying that purchase happened, but actually it belongs to not purchase happened. I repeat, this point. Okay, if you see that this actually my according to my model, because it is above the line. Okay, so according to my model, the y predict. Okay, y predict for is what? 1. I mean purchase happened. Okay, this is a prediction, but actual y is what? 0. Purchase not happened. So it is not matching, right? My prediction and the actual value is not matching. I mean, it is a misqualified. Similarly for this point, right? So for this point, what do the y predict? Y predict is saying 0 and prediction not happen, but actually let's suppose prediction happen. So again, if my y predict and y is not matching, then I can say that it's a misqualified point. Okay, so these concepts, I hope you able to understand this concept now. Let me remove this. So these 2 points I'm saying, these 2 points are misqualified point. Okay. Now, so in my previous video, I discussed that if you find something is misqualified point, okay, so what happened? There is a training happen, right? So this straight line get rotation. There will be some rotation in the straight line just to correct those points. This is everything I discussed in my previous lecture, right? So here, what will happen here? Because I found that there's a misqualification, right? So what will happen? The point, this, for example, this straight line, okay? I find that this point and this point having some problem, okay? So this straight line will try to rotate itself just to make the correction or make the qualification better, okay? So if the point, suppose this point, if this point is above the line, which is the misqualified point, right? So the straight line will rotate in the upward direction. This is everything I had discussed in my previous video. How the rotation happen graphically, everything I had discussed in the previous video. Okay, but here, if you haven't seen the previous video, so this is the basic concepts, key concepts. Okay, if my y predict, okay, if the y predict and if the y predict is equal to 1, but actual y is equal to 0. So for this point, okay, for this point is what the case. This is the case, right? For this point, my prediction is saying its purchase happened. I mean, y is equal to 1. Y predict is equal to 1. But actually, for this, purchase is not happened. So for this point, this is the case. Okay. So in this case, what happened? Rotation will happen in the positive direction. Okay, in upward direction. Okay, I can say positive direction rotation. So this line will rotate in the positive direction. Case number 2 for this point. Okay, so what is the y predict? So y prediction saying that purchase not happened, but actually is purchase happened. So again, this is a mismatch. Okay, so in this case, this straight line will rotate in the negative direction, in the downward direction, in negative direction rotation will happen. This everything I have covered in the previous video. Case number 3, this point. Okay, so this point has y predict is equal to 1 and actual y is equal to also 1. So there is no change, right? There is no misclassification. So in this case, no rotation will happen, right? This everything I have covered. If there is no misqualification, then no rotation will happen. Case number 4, for this point, right? My y predict is what? My y predict is saying not purchase happen, and actually also not purchase happen. So in this again, no rotation will happen. Okay, so this is the basic concept of perceptron training graphically. I hope these things I have already covered. Okay, though these are the 4 important cases where a line will how the line rotation will happen depending upon these 4 cases. Okay, and also in my previous video I had discussed that if the rotation happens, suppose my let me remove this. Let's suppose I have established these 4 cases, right? And also we learned that in previous video that if rotation happens in the positive direction, I mean in the upward direction, rotation happening, or in the downward direction, rotation is happening, right? So there is some how the updation happened. There's some formula, right? So we discussed that the equation of perceptron, okay, is what? W1 x1 W2 x2 plus b. That was the equation of perceptron. Okay, so this equation, after the rotation, this will get changed, right? So how the change will happen in the if it is going in the upward direction? So we discussed that W1. Okay, so here W1, W2 and b, these are my weight and bias. So this will get changed. Why the rotation is happening? The rotation is happening just to update my weights and bias. This is the called training, right? This all fundamental thing I have already covered. I hope you are able to connect all the dots. Okay, so the training of perceptron or the line rotation is happening just to update my weights so that I can get the correct weight and my points get correctly qualified. Okay, so here update will happen. So in this case, in the positive direction, if I'm moving in this case, okay, this is the case, suppose. So in this case, so my new weight will be what? W1 minus, in the positive direction we do a minus, okay, and we take a learning rate. Okay, learning rate is generally, learning rate are very small number, for example 0.01, 0.001, something like that. Okay, this all thing I have already discussed, and this one, and eta into x1. Okay, and W2 will be W2 minus eta x2. Okay, and B will be B minus eta. Okay, eta into 1. You can say this thing I have already covered in my previous video. Okay, so this is for case number 1. This is for case number 1 if the rotation happening in the upward direction. Okay, case number 2. This was the case number 1. Okay, let's suppose case number 2. If this is the case, okay, and we are doing the rotation of line in the negative direction, in the downward direction, then in that case, what is the W1? Here we will do plus. Okay, so W1 plus eta into x1, W2 is equal to W2 plus eta into x2, and B will be B plus eta. Okay, this thing we have already covered. So we have these 2 cases. In another cases, like case number 3, in this case no rotation will happen. In this case there is no change in the weight and bias. Okay, so case number 3 and case number 4 are, these are the case where points are correctly qualified, okay, classified. So there is no rotation or no update is required. Okay, so update will only happen if my point are misclassified. Okay, my y prediction update only happen in this case if y prediction and y actual are not equal. I mean the points are misclassified, only then we do the shift in the line and we update our weight and bias. Okay, this everything are the foundation. I'm again recapping. So this everything I have already covered in my previous video. Okay, how the rotation happen, how the change happen. Okay, so this is called update rule. Okay, so here with respect to these four cases, you can see that now here what I'm trying to do, how to here my purpose is based on this update rule. Okay, I want to build an algorithm so that I can build this algorithm and I can train my model. Okay, so here my purpose is to build an algorithm. Okay, and this algorithm I will call it perceptron update rule. I will call it update rule. Okay, perceptron update rule, this algorithm. Okay, so you can see that I have already discussed that these are the four cases. Only these are the four cases possible where my prediction and actual value are not matching. Okay, if it is matching, then there's no problem, there is no update required. And if if it is not matching, my prediction and actual value is not matching, then we have to do a line rotation, either in the upward direction. In this case I will do in upward direction, or in this case number two, I will do in the downward direction. These are two cases. Okay, and based on these two cases, this is the how my weight and bias will update. Okay, this is the rule. Okay, if I'm doing the rotation in the positive direction, in upward direction, then this is how my weights and bias will change. If I'm doing my rotation in the downward direction, this is how my weight and bias will change. This is all I have already seen, and this is the update rule. Okay, here now you might be thinking this looks very clumsy, and I think this equation looks very clumsy. Okay, it is not generalized. Okay, so here I want to, my purpose here is that I want to make this equation very simple, and I want to generalize this equation. Okay, I want to generalize this equation, this update tool, so that I can build a small model. Okay, so how to generalize? Okay, let us see that. Okay, so you can see that the weight, uh, if you see, if you if you see very closely this weight. Okay, so there is an update happening, there is some change happening in the weight. Okay, so for example, let's say that suppose this is my old weight. Okay, this is w is this is the old. Okay, sorry, this is the new weight, is equal to w old. Okay, it can, you can see that sign. Okay, it can be either minus or positive. Okay, there are two possibility, right? When I'm updating my weights, one second, let me make it better. Okay, so here if you see that w, okay, how the w getting changed, this w. Okay, and I want to combine these two changes into single equation. Okay, so can I write like this? W dash, I'm calling new w, new weight, is equal to w. Okay, either it will be minus eta into x1, or it can be plus. Okay, there are two signs, right? Either you can see that either can be minus, if it is direction is the positive, then it will be minus. If direction is a negative, then it will be plus. Okay, so there are only two possibilities. So how this will change? Either minus or plus. Okay, I can say either minus or plus. This is the equation. So I'm combining this equation and this equation into one single equation. Okay, so this way, after combination, I can say that w is equal to this way. Okay, and here I want to introduce, just to get the sign right. Okay, here this is my case. Okay, the case number one is this: when the negative case happens, okay, in this case, right, in this case. So here one thing I want to introduce, one thing, just to combine these two equation into single equation. I can say that w1 dash is equal to w plus, okay, uh, plus eta. Okay, and here y predict, no, one second, okay, let me remove this. Yeah, so I'm combining, I'm making it general. Okay, so here I can say that this eta into y minus y predict into x. Okay, so these two equation, okay, so these two equation, w is equal to w minus w plus, these two, first of all, these two equation I combine into this equation. So it can be only the difference is a sign, right? If it is either it can be negative or it can be positive, right? So I can combine this way. I can say that w is equal to w plus minus eta into x1. Okay, now just to combine, just to make this sign common, okay, my purpose here is that mathematically what I want to achieve here, this sign, okay, it can be either plus or minus. Okay, so I have two cases. In the case number one, either it can be plus sign, or case number two, either it can be minus sign. Okay, I want to combine this plus and minus. Okay, so that is why I'm adding one factor here, y minus y predict. Okay, y is the actual y, I mean actual label, and y predict is the prediction after that, according to the my perceptron equation. Okay, so what is the advantage of this equation mathematically? If you see that, the advantage is that this equation, okay, this equation is combining both the cases. This equation is, the advantage of that is this equation is combining, I mean this equation, okay, and this equation. So here I'm combining two cases. Okay, both the cases, positive case and negative case, I'm combining both the cases by single equation mathematically. Okay, if it is possible, which is quite possible here, then it is very easy to write code or build algorithm, something like that. Okay, so you can see that these two equation can be easily represented by this simple equation. Okay, let me explain that how. Okay, so mathematically what I'm doing here, let me explain. So I'm saying w, I have two cases, right? W is equal to w plus eta into x. This is one case. Okay, another case is w is equal to w minus eta x. Okay, this I have only two cases where update is happening. So here, in order to combine those two equations, I'm saying that this is my combined equation. W is equal to w plus eta y minus y predict into x. This is what I'm saying after combination, and it becomes my general equation. Okay, so let me explain that. After combination, it is representing both equation. Okay, so let us suppose this case. Okay, in this case, right, negative case. Okay, when the negative happens, okay, the negative happens, uh, suppose when y predict is equal to 1, okay, and y is equal to 0. In that case, we, because it's a upward direction, right? In this case, it's a this is the case of upward direction, right? And if my y predict is equal to 0 and y is equal to 1, then this is my negative direction, right? So this line, this update is representing negative direction, and this representing positive direction, right? So if I combine that just to make the sign, okay, so here you can see that if you find this equation y minus y predict, so in this case y minus y predict is what? So y is equal to 0 and y predict is equal to 1, so it becomes minus 1. Okay, so in this case, in this case, y minus y predict will give me a negative sign. Okay, in this case, if I say y minus y dash, okay, so y is equal to 1 and predict is equal to, it will give me a positive sign. Okay, so you can see that this y minus y predict, so depending upon the cases, okay, automatically y minus y cap or y predict is giving me sign. Okay, so it can be either positive sign or negative sign depending upon the case, whether it's we have to do rotation in the upward direction or in the downward direction. Okay, so this is called update rule. Okay, so the update rule is just you have to remember what is the update rule. Okay, what is the update rule? So after this discussion, we find that my update rule is this: how to change my weight. Okay, because this is a part of training. Okay, how this you have to establish this concept. Whenever you are training your perceptron model, you are updating your weight and bias. So how the update happen? So this is the equation for update. Your new weight will become W old weight plus eta into y minus y predict into x. Okay, this is what you have to remember as part of update rule, and this is how equation change. Okay, for bias, what will happen? B old bias plus eta into y minus y y predict. There will be no x component. Okay, so this is how weight and bias gets updated as part of training, of perceptron, and this is the mathematical equation, right? Okay, so let me explain you again. So what we okay, so here let me so what we cover here. So I have two cases. Okay, for if the points are correctly classified, if there's no any problem, okay, then there's no update required. Okay, I repeat, in the perceptron, if the point is correctly classified, then we don't have to update our weight and bias. Update will happen only in these two cases: whenever my points or are misclassified, when my prediction and actual value is not matching. Okay, when my y predict and y, if it is not matching, only in this case we do the update rule. Okay, so according to these two, we have two cases. Okay, one case is this: when my y prediction, I mean the points are above the line but it should be below the line. Okay, or second case, when the points are below the line but it should be actually above the line. Okay, so these are two cases. These are only two cases possible when your points are misclassified, right? So I have four cases now. Okay, the first case is this one: when my y predict and y is not matching. The first case, second case also not matching, and third case and fourth case when both are matching, my y predict and y actually is matching. Then in these three case and four case, we don't have to do any rotation or no update is required. Okay, only update is required in these two cases: when my y prediction and y actually is not matching, and then we have to do rotation. So rotation I can do, I have already covered in very detailed video, graphically, geometrically, how the line got rotations, everything I covered in very detail. So but if you have to remember this, if this is the case, okay, if my points are above the line, okay, I mean if my prediction saying 1 but actually 0, then we have to do positive rotation. In this case, if my prediction is saying 0 and actually is equal to 1, I mean below the line, we have to do negative rotation. Okay, why positive rotation, negative rotation, we already covered in my previous video, but this is the formula you have to remember. Okay, and how the weight will get changed: in case of positive rotation, we apply negative sign. Okay, so new weight will be weight 1 old weight minus eta. Eta will take any learning rate. It can be in a small number. Generally, we take 0.01, 0.001, something small number. Okay, and x1. This is how it gets updated. Okay, in case of upward direction, we put negative. In case of negative direction, we put positive. So you can see that whenever we update, okay, the sign will the only difference is the sign. Okay, it can be either, you can see that it can be either plus or minus. Whenever we updating our weight, either it can be plus or it can be minus, depending upon the case. Okay, either it's a first case or second case. So now I want to combine these two equations. I want to make a very common equation, update equation, so that I can use that in my programming. Okay, so how to combine this plus minus? So just to combine it, I am introducing this factor, this subtraction, y minus y predict. Okay, because y minus y predict will give me sign, either positive sign or negative, because I need to find the negative or positive, right? So this will give me negative, positive. Okay, so this is the update rule. After combining both the equation, either positive, negative, my common equation will be like this: w is equal to w plus eta y minus y update into x. Okay, so if you combine these two equations, plus minus, this will give the equation. Okay, and it will cover the both the cases. Okay, so now guys, you have to remember. Okay, now you are able to understand, right, how this update rule came. Okay, what is the origin, what is the concept, what is the mathematical intuition behind this common equation, right? Update rule. Okay, so this is the update rule. Okay, where your weight and bias will get updated. Okay, so in case of, again I'm repeating, this will apply only when your points are misclassified. Okay, let me show that. Okay, let's suppose my y prediction and y uh, actual both are same. Okay, if you find the difference, suppose I'm finding this factor, this equation, so y minus y predict both are same, so it will be 0 in this case. Okay, let's suppose there is no any misclassification, then this difference will be 0, right? So in that case, okay, so this whole part, so this becomes 0, this becomes 0, so this whole component will become 0, because if you multiply anything by 0, it will be 0 mathematically. We know that mathematic, right? So this whole part will become 0. So the new weight is become old weight. Okay, so in this case, what happened? In this case, your old weight, new weight will be equal to old weight. I mean, there's no change. Okay, so new weight is equal to old weight. So during the update, there will be no update in the weight. Similarly for bias also. Okay, so you can see that this equation is covering all the four cases. This equation is going to cover all the four cases. I cover all the four cases. Okay, so one equation is all four cases, right? This all the four cases has been covered by simple one equation. Okay, so this is called update rule. I hope you're able to understand that. Okay, now if you're able to understand this update rule, now I'm assuming that at this point you're able to understand, you have the basic concept that how the weight gets updated. In my first video, when I was talking about the perceptron, how the perceptron works, right, I was talking about update. When we do a backward propagation, we have to update our weight and biases. Okay, so how the weight happen, how the update happen, this is the equation. Okay, equation is this, it is called update rule. Okay, now, based on this formula, let us build some code, and I will show you code that how the real update happens behind the scene. Okay, this is everything. Okay, so here this is the formula. Okay, let me go there. Now this update happens. Okay, let's suppose yeah. So how the update happens? This is the update formula, or you can say update rule. Okay, how the perceptron apply that. Okay, so we know that we have the equation now. New weight is equal to old weight plus eta, we take learning rate, and y minus y predict into x. I have this equation, right? And for bias, I have plus eta into y minus y predicts. I have this equation now. We find this equation. Okay, so how the perceptron works, how they build the they do the trainings. Okay, how they do the trainings, let us explain you. Okay, so here what does what the perceptron does, it will take any, suppose let's suppose I have this data point. Okay, I'm just taking 4 data point. It can have multiple data points. Okay, here I'm just explaining, just make it simple. So I suppose I have suppose I have 10k data points, 10k rows. Okay, 10,000 rows I have. Okay, and I want to train my model on this data set. I will train my model. Okay, so what happens behind the scene? Okay, so it will take any random. Okay, this is the algorithm. Okay, it will take any random data point. Let's suppose it is taking this data point. It will take any data point. Okay, at random data point. Okay, so let's suppose in the network I will feed 3 1. I'm taking this data point. Let's suppose I will feed 3 1. Okay, this data point. Okay, and for this data point, what it will does, it will find the this for this data point. Okay, it will find the w, because this data point I have some w, I have initialized some w and weight and bias, right? So for I'm saying that this is x1, this is x2. Okay, mathematically. Okay, so you know that as a training part there are two processes. One is called forward propagation. Okay, and another is called backward propagation. Okay, I have already discussed in my previous video where I was talking about the foundation of perceptron. Okay, so how the training happens, it will take any random data points, okay, and the first part it will calculate as part of forward propagation. It will calculate this one. It will do metric calculation of w1, okay, into x1 plus w2 into x2, and it will take some bias, okay. So if you remember that, let's suppose, if you remember, right, that, one second, let me make it small. If you remember, this is my model, this is my neuron, so this is my perceptron, right? And this perceptron has what? It will do summation and it will apply the activation function, which is a step function, okay. And here we in giving two inputs because I have two features, okay. So let's suppose I'm giving here this is the salary part and this is the city part, right? So here my salary is 3, I'm taking here, I'm giving 3 here, and city I'm giving 1, right? And this neuron, as you know that, if you have seen my previous video, we assign some weight. So I have two input here. I suppose I'm calling it x1 and I'm calling it x2. So I have two weight, I have two input, x1 input and x2 input, right? And these 2 points are connecting with that, okay. So for x1 I am giving taking weight w1, and for x2 I'm giving weight w2. This is everything, I have covered everything, okay. So now I have x1, I have x2, okay, and I have to weight w1 w2, okay, and I will take some bias of this. So suppose bias is equal to b. This is the setup, right? So what happens with this setup? So as part of training, it will take any random points, any x1 x2, okay, and it will do the forward propagation. This is the forward propagation it is doing, okay. And as part of forward propagation, it is nothing but a dot product, right? So w1, whatever w1 I have taken, so w1 into x2, w2 x2 plus b, and then it will apply a function. What is function? Step function, okay. So in this apply, it will apply a z on this, I mean a step function, okay. So this step function will give either 0 and 1, you know that, right? So this will, so this whole thing, I'm calling it y predict. Let me make it better. uh, this whole thing, this is how the training happens, okay. So yeah, so here it will apply the function, which is step function, and the output of this is called y predict, okay. So this equation is nothing but a forward propagation in perceptron, okay. So it will do this calculation, okay. I got the y predict, okay. And then for I got the prediction, right? And let's suppose a prediction I got, suppose 0, okay. And for this data point, you can see that 3 and 1, I'm finding that prediction is 0, but actually it is 1, right? So you can see that y predict here, y predict, I'm saying 0, and y actually is 1. So it is not matching, okay. So here it will check if y predict, or you don't have to check, actually you have to apply this function, okay. One second. So let's suppose you got this, okay. You got this, right? So now here in this case you have y is equal to 1 and y predict is equal to 0, okay. After forward propagation, we know that what is my y predict, okay. Now on this I will apply this formula, which I find, right? I will apply this formula, and the formula is like this. I will apply my update, okay. Now I have to do what? This is my forward propagation. Now I have to apply the backward propagation, okay. I mean I have to apply the update rule which I covered. Mathematically I got one algorithm, okay. So my new weight w1, okay. So w1 will be what? New weight will be w1 plus my weight will be what? Plus eta y minus y predict into x. This is the equation, right? So if we calculate, so w1 plus eta will be some number, let's suppose 0.01, okay, and y minus y predict. In case if we find that I have already y predict after the forward propagation, so y is equal to 1 and y predict is equal to 0, okay. and x. What is my x here? I have my coordinate, right? My x is what? 3 and 1. Okay, so I have 3. Let's suppose I have first one 3. Okay, so it will find the w1. Okay, so this number I have, right? So w1 will be some, suppose some old weight, and this way I will find the new weight w1. Okay, similarly for w2, it will do same equation. W2 plus eta is equal to 0.01, difference is equal to 1 minus 0. And for W2, what is the x2? X2 is equal to 1 into 1. Okay, so this way if you do the calculation, you will find W1 and W2. Okay, and also you will find the B, right? So what is the B here? B old plus eta 0.01 and 1 minus y. Okay, this way you got, so this way you can see that applying the update rule, okay, I got my new W and calling it W1 dash, W2 dash and B dash. Okay, so I find my new width and bias for this point after the update rule. Okay, so this happens for one data point. Okay, so for one data point, what is happening? It is taking any data point at random. It is doing the power propagation. It is applying this formula. Okay, and it will find the y predict. Okay, and then it will find the update rule. It will update the weight and bias like this. Okay, and after update rule, according to this rule, it will find new weight and bias. Okay, so my weight and bias got update. Okay, so this is one loop. Okay, similarly, it will start for the next point, next data point. Okay, and it will repeat the same thing. So for next data point, it will do the forward propagation. Okay, and it will find, after that it will find y predict. Okay, and then again it will do the backward propagation. It will again update my weight w1 w2 and bias. Okay, so this happens for all the data point. Whatever data points I have, let's suppose this, and it happens in a loop. Okay, so this whole process, okay, for all data point happens in a loop. Okay, so I can apply a loop here. This everything is happening in a loop. Okay, so now let me make it simple. Okay, so what is happening here? So this is the algorithm. Okay, so what is happening here? We are taking a loop. Okay, I'm writing in a simple pseudocode, starting a loop. Okay, and this loop, I can decide, I can run this loop, suppose 100 times, or suppose that depends. Okay, how many times you have to run, I will talk about that, but generally we run 100 times. Okay, so that we get the right fit line or conversions happen. Okay, so we take a loop. Okay, and inside the loop, what we'll do inside the loop, okay, do these points. First one, we take any random point. Okay, for any random, any point, any data point, we take any data point inside that, and we do forward propagation. Okay, and after forward propagation, basically we are doing this, we are applying this, right? We are applying z w1 x1 w2 x2 plus b. Okay, and it will give me y predict. This is what we are doing. Okay, and then step number 2, we are applying the backward propagation, or we are applying the update rule. Okay, and here we are updating our weight. How the rule is w is equal to plus eta y minus y predict into x. Okay, so these two equation, these two operation, forward propagation and backward propagation. After backward propagation updates, my weight and bias got updated. My bias will also get updated like this, eta y minus y dash. Okay, so these two operation will happen in a loop, in a for loop. Okay, these two operations are happening in a for loop, suppose 100 times, 200 times, and finally after this you will get a, what is the result of this iteration? You will find a right straight line. Okay, graphically, basically what you're doing, basically you are trying to find a right line so that it can separate. Let's suppose I have multiple data points, I can separate multiple data points into different clusters. Okay, so this is how the update happens. So this is the simple algorithm, this is the simple this is everything. This is a simple algorithm for update. Okay, and this is all thing is called training. This is what called training of the perceptron. Okay, and after the training it find the right, the purpose is what, to find the right fit line to separate my cluster of point or cluster of data, and this is the equation behind that. Okay, so let us understand this. Whatever I discuss here, it's a pseudo code. Okay, let us discuss with the code. I will give an example with the code so that you will have a better understanding. Okay, so it's very simple formula. Okay, so for that I have already written a code. Okay, so here let me explain the code. Whatever I discuss here, okay, the same this algorithm. So same algorithm I'm writing in a code, in a pseudo code, in a code. Okay, so that you will understand how the update happens. Okay, so let me explain that. It's very simple. Okay, so here let me run this cell. I'm explaining everything. So here I'm creating some data point. I'm using panda numpy. Okay, and sklearn has a class uh, function called make classification. Okay, I hope you already know if you have done ml projects. So I hope you already know that. So I'm using ml classification, and here I'm from the ml classification I'm generating two data point. Okay, my number of feature are two. So I have only x1, x2. If I say number of features is equal to 2, I can take 2, 3, 4 into multi-dimensional, but I'm taking just two feature, okay, x1 and x2. And if I run this, okay, so you can see that this is my x, this is my features, okay, and this is the x1 feature, this is the x1, this is the x2, okay, and for every x1, x2, I have a corresponding label, okay. So you can see that this x is the features and y is the label, okay. So in order to show you y, this is my y, okay. So you can see that for this pairs, for this x1 and x2, okay, what is my actual value? My level is equal to 1. I mean purchase not happen. Let's suppose just try to understand uh, that this is the salary, this is the city part, okay. This is the salary, this is the city, and based on the salary city, I'm saying that purchase happen or not happen. So 1 is saying purchase happen and 0 is saying purchase not happen. Let's assume that is the data set. Okay, very simple. And what is the shape of x? So I have total 100 data point. I mean 100 here. Let me explain that. I have total here according to my code. Okay. So I have taken two features. So this is the data. Okay. I have x1, I have x2, and I have y label. Okay. And here I have 100 data points. Like there's multiple rows. I have multiple rows. So this is the first row. Suppose it has some data and some label like this. So till that I have 100 rows. Total I have 100 rows in my data point. Okay. I mean 100 observation. Okay, now in order to show that I'm just plotting a scatter graph, okay, just to show the data. Okay, so this is the data look like this. Okay, I have two classes. You can see that it is very easy to separate, right? So I have two classes. This one, this class belongs to this cluster, and yellow one belongs to this cluster. Okay, so you can see that this is this kind of data set is linearly separable. I can easily separate this line, this data point, using a straight line. So here I can find a line here, okay, and I can easily I can separate it. Okay, so the perceptron, the whole purpose of perceptron is what, to find a right fit line so that you can separate two different clusters. So I have here two clusters and I want to separate it. Okay, so how to train this model? So here it can be multiple lines. I can try I can find here multiple lines, right? One, two, there could be infinite lines, right? So how to, which is the right fit line? So that is the whole purpose of training. Okay, so as a part of training, you're trying to find the right boundary so that you can separate the two different classes. Okay, so how to find the right right boundary? So for that, I'm applying the same concept. Okay, I'm applying this concept, this algorithm which I discuss right now. I'm applying this algorithm. Okay, so in order to apply this algorithm, you know that what we need some step function, we need the matrix calculations, all things we need, right? So for that, what I'm doing, I'm adding a step function. Okay, guys, don't worry. This everything which I'm explaining that you don't have to do manually. Okay, I will show in the next video that we have already this everything is done automatically behind the scene. We have a model for that. Okay, We don't have to do this kind of calculation which I'm showing right now. This is only showing just to explain the concept, just to conceptualize it. Okay, we don't have to write this whole code, but try to understand how the training happens. So this is my step function. Okay, so you know that a step function is what? If the input is more than 0, then it will be 1, otherwise 0. This is all thing I have covered. Okay, and here let me remove this. Okay, this is my step function. Now whatever I discuss here, this part, okay, whatever I discuss here, that we have to take a loop, okay, and then we have to take any data point, we have to do forward propagation, apply the Z rule, and then we do update the rule. This everything what I discuss here, same thing I'm doing here with the respect of code. Okay, again, I'm again saying this everything you don't have to do. This whole part basically when we use a ready-made function or ready-made model, which we have, okay, in sklearn we have a perceptron model. We don't have to do these things, but here I am trying to explain how the things happen behind the scene. Okay, so here let's discuss, right? First of all, you have to decide one. Okay, first of all, this part, this loop. Okay, this loop we give a fancy name in the machine learning. We call it epoch. Epoch. Okay, so epoch is nothing but a loop. I mean iteration. Okay, so here you have to determine that how many times you want to perform this action or this operation. Okay, so here I'm saying that my epoch is 1000. Okay, it can be generally 1000 is good amount of epoch. Generally conversion happens. Okay, so let's suppose I'm giving 1000 epochs. You can try with multiple numbers. Okay, unless until you don't get right fit line. Okay, but we give some we try some. Okay, we give some random epoch 1000, something like that. Okay, and here I'm giving I'm taking one learning rate, eta. I told, right, we need eta, the learning rate. Okay, so learning rate I'm giving 0.01. Okay, you can change it. Okay, and I'm taking, this is my x input and this is my y label. Okay, and this is my, I'm building a function. Okay, so this whole thing which I talked about right now, this everything I'm putting inside a function. Okay, and for that function, this is my input. My input is what is my x, which I know that. What is my y level, I know that. What is my learning rate, I know that. What is my epoch, I know that. Okay, and here what I'm doing here, so as you know that in my previous video I discussed, right, whenever we do line rotation, okay, we add let me this this point I have already covered, but again I'm reiterating. Okay, if you have seen my previous video, okay, when I discuss about the graphically, okay, how the training happens, in my first video I discussed that. Okay, so let's suppose, I'm giving example, let's suppose this is my x and this is my y. Okay, and this is my, suppose this is my wx, wy and b. This is my perceptron, right? And let's suppose this is the point which is a misclassified point. Okay, and let's suppose this, for this point axis or the feature is suppose 2 and 3, right? This is the x feature, this is the x1, and this is the x2. Let's suppose this is a setup. Okay, and this is my line. Okay, and let's suppose I know that this point is misclassified. Okay, and it is in upward direction, right? So we have to move this straight line in the upward direction. The rotation will happen in the upward direction, as you know that. Okay, so for that, if you remember how we apply mathematically. Okay, so here let's suppose suppose my weight, I have taken some weight. If I suppose the formula, this equation is suppose 4x plus 7y plus 8. This is my perceptron. Okay, so 4 is the my weight. This is my w1, 4, w2 is 7, and y is equal to 2. Let's suppose this is my perceptron right now. Okay, and if I want to do a transformation, if you remember that what we did, okay, so we add one number here in the feature, we add one number, 2 3 1. Okay, if you remember, so the equation will be after the rotation, the new line. Okay, so new line equation is like this. Okay, so we take 4 here, we take 7 here, we take 8 here. So these are coefficient of our perceptron. 4, I mean these are the weight. Okay, this is the w1, this is w2 and weight. Okay, and I take here 2, the features 2 3 2 3, and 1 I have added here just as a bias. Okay, I added 1, and then we subtract because we're moving into upward direction. We do subtraction. Okay, so after subtraction, 4 minus 2 2, 7 minus 3 5, 8 minus 1 7. Okay, so the new line becomes what? 2x 5y 7. This is everything I had discussed in my previous video. Okay, so that is why we introduce here 1 into x. Into features, we are introducing, we already have x1 x2, already have 2 3, right? Already I have x1 x2, I'm adding 1 here. Okay, so whole concept I think I have already discussed. Again, I revised it. Okay, so that is why what I'm doing here, see, I have already x, I have already x, this I have. Okay, and in x I have already 2 points, these 2 points. Okay, I mean these 2 points nothing but the coordinate. these are these are the coordinates, suppose 2 3. Okay, so here in 2 3 I want to add 1. Okay, as per the rule. Okay, so that is why I'm doing this. That is why I'm adding here, inserting. Okay, I'm inserting in x. There's an np, this is the numpy formula, numpy function to insert something. So I'm inserting x at 0, I mean the first column. Okay, right now I have these 2 columns. Okay, I have in x I have these 2 columns, this first column, second column. Okay, so at the 0th column here, at the 0th column I'm introducing 1. Okay, so after insert it have 3 columns. Okay, so right now it will happen here. Okay, so right now here it will add 1 here, so it will be 1 comma this point and this point. Okay, so why I'm adding that, I hope you got the essence, right? I explained that, right? Why we adding here, this why we adding here. Okay, so here let me go back. Okay, so here so here we are adding in the x, we're inserting at 0 column 1, we're inserting 1. Okay, axis 1 is vertically, I mean vertically I'm adding 1 here. Okay, so after this point, okay, my x before insertion, x has 2 columns. After insertion, x will become 3 columns. The first column will be 1, and after that second and third column. Okay, so this will become x. Okay, now here I'm taking some weight. I told that we know that we have to initialize some weight when we start the perceptron, right? If you remember here when I was discussing, right? Uh, okay, here when it's gone again, I think I removed that. Okay, so as you know that when we build this perceptron, right? When we build this perceptron, we have the input layer, right? And we assign some weight here, w1 w2 weights and bias. We take some weight and bias, right? We initialize some random value. So that is what we are doing here. Before I start the training, I'm taking some weights. Okay, I'm just inserting ones. Okay, so what is the shape of x? Okay, so here what is the shape of x? I mean uh, it has three three columns, right? So it will create the weights for x1 and x2. Okay, so it will I mean now here the x. Okay, so x has 3 columns. The first column is equal to 1, then x2, then x3. So for x1 and x2, okay, it is creating the weights. Okay, so I got the x, I got the weights. Okay, now I discussed, right? I have to run this two operation. I mean forward propagation and backward propagation into a loop, into epoch, right? This whole 2 operation will run in a loop. So that is why I am taking a loop here. Okay, I'm taking loop here. Okay, and loop I have determined. I want to run 1,000 loops. Okay, and here now I have to do forward propagation and backward propagation, right? So here in the loop what I'm doing, I'm taking any random data point. Okay, you can say that you can see that I'm taking for x from the x. Okay, x dot shape 0. Okay, uh, okay, x dot shape 0. Okay, it will give me the rows. Okay, number of, if you see what is the x dot shape here, let me explain that. If you see the shape, okay, the shape is what it is giving the rows, right, and the number of column, right? So here after this line, if I insert this, my shape will give this 0 100 rows and 3 columns. After insertion I will have 3 columns, right, not 2 columns. Okay, so here Out of 100 rows, I need to take any rows. Randomly, I want to pick up any rows out of 100. What I'm trying to say here, let me go to the graph. So let's suppose I have this data set, okay? So suppose I want to pick up this randomly, I want to pick up this row, okay? This row, right? So for this row, I want to get the row number. What is my row number? Okay. So for getting the row number, how I can get the row number? So here out of 100, I can take any number. Okay. So randomly, I'm selecting any number. Okay. You can see that x dot shape 0. X dot shape 0 is what? My rows. Okay. Number of rows. It can be 2, 3, 4, 5, 6, 7, 8, anyone. Okay. And then I'm creating any random number. Okay. So for 100, my shape is saying 100. So it will create any random number in between 100. It can be random number, can be 1. So J here, okay, so J here can be any random number. It can be 1, between 1 to 100. Okay, so this line is producing a random number between 1 to 100, anyone. Okay, so I got my index. Okay, so for this data point, okay, here I'm doing the forward propagation. So this line is nothing but this line, this forward propagation. Okay, so here I'm applying what? See, you can see that np dot dot, I'm doing a dot product of x between x and weights. I have the weights. Okay, so I'm taking any weights here. I'm taking any weights. Okay, and j is my random number. I have taken any point from my x. I'm getting that j, okay, and applying the weights. Okay, and this is my dot product, and after the dot product, I'm applying the step function. So this whole process is nothing but what? Forward propagation. Okay, and it will produce me y hat, I mean y prediction. You can see that same thing I've written, right? So if I apply if I do dot product and step function, it will give me y predict. Okay, this is what I'm doing here. Okay, so this is give me y prediction. Okay, so once I get the y prediction, so this first operation is done. Now I have to do I have to apply the update formula, this formula which I cover, right? So here same thing I'm doing. So my new weight, okay, this is the formula, right? So new weight will happen. How we update the new weight? Old weight, which is this one, plus learning rate. I mean this formula. Just try to remember this formula. Weight plus eta y minus y predict into x. This is the formula, right? So this formula I'm writing in code. Okay, so weights plus eta, this is my learning rate, into y actual, this is the y actual minus y predict. So this is nothing but y minus y predict, or into x. This is my input. Okay, so this will give me what? New weights. Okay, so new weights for x1 feature and new weight for x2 feature. So it will give me two weights. Okay, one for x1, one for x2. Okay, and it also will give me so here it will give me three things. Basically it will give me three things. First thing, okay, the first one, it will give me the bias. Okay, yeah, it will give me the bias and the weights after one. Okay, so this weight will have I mean it's an array. Let's suppose it's an array and it has three inputs. Okay, so this weight after calculation, let's assume this. Okay, so the weight here, this will give you three things in the array. Okay, first thing will give you suppose bias, and then first for x1, suppose I have input x1 and x2. So for x1 I need to know weight, for x2 I need to know weight, and I need to know bias. Okay, so this weight matrix will give you weight w1 and w2. Okay, this everything, this is all you're getting here in this matrix. Okay, so here I'm returning a tuple. So here I want the weight of 0, I mean I want the bias, and anything after weight 1, I mean I want to get the weight 1 and weight 2. Okay, so this is my formula, and whatever I explain you in words, this everything I'm just representing into the code. This very simple thing. Okay, I hope you're able to understand this code very pretty. It's very pretty simple. Again, I'm finding x and weight, I'm running the epoch, I'm taking any random number and applying this forward propagation, applying the weight calculation, update rule, and I'm finding my weights. This simple thing I'm doing right now. Okay, let me run this. Okay, Okay, so if I call this function, I'm calling this function because I have x and y. Okay, so it will do the calculation, and ultimately I will find my because it will give me tuple. Okay, so this number, this return type, I'm calling it intercept. Okay, and this return type, I'm calling it coefficient. Any w1, w2. So you can see that intercept is this. So this is my bias. Okay, and my coefficient is this. You can see that it has two weights. So this is my w1, this is for w2. Okay, so after running all the points, I mean after running 1000 loops, okay, it is running 1000 loops. So I have one thing, I have how many data points? So I have 100 data points, right? I have 100 data points, right? Because I have total 100 rows. Okay, and I did a loop, for loop of 1000 times. 1000 times I did a loop, and in every loop, what I'm doing, I'm selecting any data points randomly. So out of 100, I'm taking any data point. This can be one, this, any one data points. Okay, and then I'm applying forward propagation, I'm applying backward propagation, and finally, after this iteration, I found the my weight w1, w2, and bias. This is what I'm doing, right? So you can see that my data points is just 100, but my number of iteration I'm doing more than data points 1000 times. Okay, so maybe that chance, like maybe data point will repeat here. Okay, that is not a problem. Okay, so this way, after this iteration, I will find the right fit line, and for that fit line, I need to find what is the coefficient, weight, and bias. I find that. Okay, this way I find the weight and bias. Okay, now I want to draw the line. Okay, so here, as of now, after this iteration, what you find? Okay, you find three things. You find uh, suppose I want to draw a line. Okay, so in order to draw a line, what we need? We need wx plus w1 x1 w1 x2 plus b. This is what you need, right, to draw a line, right? So I need w1, I need w2, and I need bias. This is what I need, right? I need three things to draw a line, right? Which I already got it. After this iteration, I found w1, w2, and b. I found that, right? So this all, and if we have these three information, I can draw a line. Okay, so here, my friend, I have this all three operation. Okay, so here, one thing, this whatever you got here. Okay, so actually whatever you got here from this equation. Okay, so you got this thing. Okay, actually you got coefficients. Okay, so here, my w1 into x1 plus w2 into x2 plus b, right? So I find, from this equation, after this I find what is my w1, what is my w2, what is my b. I found that. Okay, and you can see that this is a straight line. Basically, this is a, let's suppose this is basically a straight line, right? So I want to draw, let's suppose, if you know that, if you really want to draw a straight line, okay, what is the equation of a straight line? Y is equal to mx plus c. If mathematics, okay, if you know, if you understand, if you know what is my m and c, m is called slope, is mathematics, and c is called intercepts, right? So in order to draw graphically, I want to draw a line. So in order to draw a line, I need to know what is my m and what is my c. Okay, if I know my y and c, I can draw a line. Okay, so let's suppose my equation, I got equation in this format. Okay, from this format, I want to transform this equation into y is equal to mx plus c format, so that if I'm able to transform this equation is equal to y is equal to mx plus c, then I can know that what is my m, what is my c, then I can draw a line. Okay, so how to do that? It's very simple, right? So here, let's suppose here I'm calling it, suppose this is my w1, I'm calling it x, w2, I'm calling it y, this I'm just representing my second feature, and this is one I'm calling b is equal to 0. Okay, I'm just doing some maths here. Okay, so if I move this, because I need to find the y, right? I need to find the y, so I'm keeping this component in one side, w2 into y, and I'm moving this component into in the other side of equal. So this will become minus w1 into x minus b. Okay, this is I'm just doing a simple elementary math. Okay, and then y is equal to, I will divide by w2, w1 by w2 into x minus b by w2. Okay, so I transform this equation into y is equal to mx plus c. Okay, you can see that now this portion is what is equal to m slope, and this portion, okay, this portion is what is equal to c. Okay, so I can find that my m is equal to what, w1 by w2. Okay, and my c is equal to coefficient by w2. So I find these two terms mathematically, right? I hope you're able to understand the math. Okay, so now the same thing I'm doing over here. Okay, so I have intercept, I have two coefficients. So in order to draw a line, I want to find m and c, so that I can draw a line y is equal to mx plus c. Okay, so that is what I'm doing here. I'm trying to find my y. Okay, so y is what? So I'm trying to find my m first. Okay, m, the slope. Okay, so slope is what? Slope is equal to w1 by w2, and first coefficient by second coefficient, right? So here that's what I'm doing. Okay, this is my first coefficient and this is my second coefficient. Okay, so coefficient, you can see that coefficient is just nothing but it's a array. Okay, because it has two components, it's a two element. Okay, so I'm taking the first element by, so in order to find the m, I need to get the first element and divide by second element, right? That's what I'm doing, right? So you can see that in the m coefficient 0, I mean the first element divided by second element. So this will give me m. Okay, in order to find a c, what I need to divide my intercept by w2 on the second element, right? So same thing I'm doing here. I'm dividing my intercept by second element, which is coefficient of 1. Okay, so this equation will give me m and c. So this is exactly same thing I'm getting from m and c, right? So this way, if I get m and c, then I can draw a line. Okay, so here what I'm doing here, I'm taking just x input. I'm using line space. Okay, I think this all thing you understand. I'm taking any random number. Okay, and on that I'm drawing a line. Okay, using m into x input plus c. So this will give me a straight line. Okay, let me run this. Why this whole thing I'm doing? I just want to draw a straight line based on the intercept and coefficient. Okay, and these are my input. Okay, so if I plot this everything, okay, if I plot this everything, you can find that these were my original data points, the first cluster, second cluster, and after the training I got this straight line. This is straight line. Okay, so in order to draw this straight line, okay, uh, this is what I'm plotting here. Okay, so how I'm plotting this, how I can find the straight line based on this coefficient, based on w1, w2 and c. Okay, because the straight line is equal to what? Y is equal to mx plus c, and in order to find mx plus c, okay, my m is depending upon this the weights and bias. Okay, so after the training I found my what is my weight, what is my bias. Okay, so these all things, this m and c I can only find after the training. Okay, and then I can find the straight line, right? So you can see that this way it is finding kind of fit line. Okay, and this way that is by the whole purpose of training a model, right? I have a given data point, and for data point, if you know the graphical, right? Graphically, what you're doing, basically you're trying to find the right fit line so that you can separate two groups, cluster of groups. Okay, if it is in two dimension, you find a straight line. If it is in more than two dimension, three dimension, you find a plane or hyperplane. This everything we have covered, right? So guys, this is the again, this is how the update happens. I have taken a lot of time. In my previous video I try to understand whether graphically I find the update rule. Okay, and actually how the perceptron does the uh, operation behind the scene. So this is the main concept here. Okay, it take any random data point, it applies a loop, it applies inside a loop, it does a power propagation, it find the y predict, and it apply the update rule. This is the update rule, and according to update rule it will find the new weights and bias. This is all thing, this is everything. Okay, and eventually it will find the weight and bias, then you will find the best fit line. Okay, so this is the purpose of training. This is the purpose of training, to find the best fit line. Okay, so this is all in this video. I hope now you are able to understand this training part, okay, this algorithm. Okay, so let me recap what we covered in this video. First of all, we try to find the update formula. Okay, and my update formula is this. Why this is my update formula? Okay, this is my update formula. So initially, in the initial part, I was trying to build the concept that how to find the this weight update formula and bias update formula. It is called update rule, and if you are able to find this update rule, then you have to apply this algorithm. Okay, and this, according to this algorithm, it will update your weight and bias, and finally, after a lot of epochs, okay, you will find the right weight and bias, and then you will able to find the right fit line. This is called the training of perceptron. Okay, so ये पूरा story है behind the training of perceptron. I hope you able to understand. If you still not understand, if you still have confusion, doubt, then put in comment box. I will try my best to answer that. But this is the whole crux. Okay, and uh, this this code I will share with you. I will share the link. You can download it, and I will suggest you run this code and try to build some intuition behind the training, how the training happened in a perception model. But this is a whole algorithm. Okay, so this is all in this video. I hope you got a lot of understanding about perceptron and got how the training happens. So as of now, I have covered the basic of perceptron. What is the perceptron? Graphical intuition, how the how the training happened, the rotation, and then what is the upgrade rule and what is the algorithm, and also I agree the code. So this is the whole concept of perceptron training and update rule. Okay, I hope you got a lot of learning. This is all in this video. In the next video, I will come back and I will give more example. I'm planning to create one project. Okay, this everything. One thing I want to before I close this whatever I discuss with you, this everything you don't have to do manually. Okay, in order to do this, we already have a model. I will talk about that. We call perceptron model in sklearn. We already have a pre-trained model, and that this everything is done by that model. Okay, this whole logic, how to update, building, learning, this everything, all the logics are written there. Okay, you just have to use that, just plug in that model, and you can solve your problem. But here I wanted to explain everything so that you have a very basic foundation, basic concept. Okay, so in the next video, I will give you one project using perceptron sklearn perceptron model, and I will explain that how simple writing the code is. So simple if you understand this basic foundational background. Okay, so I will come back in the next video. I will give you explain the perceptron model, how to use sklearn model, and these things are very simple. Okay,